All right, so now we're going to talk about a frequency distribution, right? So what a frequency distribution basically is once you've collected your data, and this is talking about quantitative data, right? So your numerical data. What do we want to do with it, right? There are some calculations that we can do on it, and then there's some graphical displays that make sense to show as well, just to kind of get an overall sense of what the data is trying to tell us. Right? So a frequency distribution takes our numerical quantitative data and just sort of counts how often those data pieces show up in a class or an interval. So it's almost a way of making our quantitative data into qualitative data, right? Sticking it into numerical categories. And so when we're looking at our raw data, so our actual numbers, we'll create some set of intervals that makes sense to look at, and we'll talk about how to come up with those intervals in a second. And so in whatever data this frequency distribution is supposed to be showing us, they've created some intervals here that go from 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, right? And then they just took the raw data, the actual individual numbers that we got from our data, and started figuring out how often a data piece fell into those intervals. So these tally marks tell us that 5 of our data pieces, 5 of our students fell into the 20 to 30, whatever this is supposed to be, class RS. I'm not sure what that is. It's just a random example, right? So 5 students fell in, gave us results. Data pieces that would fall into that 20 to 30 category. 8 with the tally marks or the count there fell into 30 to 40. 9 of our data pieces fell into 40 to 50. 10 fell into 50 to 60, so on and so forth. Now, setting your classes this way or your intervals this way is perfectly fine. And what I mean by this way is they're nice and round, right? They're just 10 wide, which is a nice round number to kind of create your intervals in. It's easy to figure out where our data pieces fall. But if you notice, the upper limit of one interval is the same as the lower limit of the next one. And so if you're going to do it this way, which is perfectly fine, you have to define where 30 would fall. Should 30 fall into the lower interval or in the upper interval? And that will completely depend upon you, and the decision you make there will affect your distribution. But again, it's creating a frequency distribution is just trying to get an overall sense of what our data looks like, right, as a group. As you can tell, we don't see the actual data entries. We don't see the actual 5 numbers that fell between 20 to 30. We just know that 5 of them did. So you're losing some of that aspect of the data, of knowing exactly what each data piece is. But what we're gaining out of that is just an overall sense of what the data is trying to say, right? So let's talk about how to create a frequency distribution. First of all, you want to decide on how many classes or intervals that you want. A typical number of classes or intervals will fall between 5 and 10. Ultimately, it doesn't matter. This is entirely up to you. But as a general rule, we'll kind of try to keep them between 5 and 10. And what determines how many classes or intervals we have just really depends on what number of intervals give us a nice picture in terms of a graph we will get out of it. So here's a set of 32 data pieces where we asked how many texts do you send a day from a class from 2013, right? Back when texting was still happening and not Snapchat. But anyway, here's our raw data. We're going to take each of these data pieces and have them fall into an interval. So we're going to lose the actual data pieces themselves, but we're trying to just get an overall sense of what the data looks like. Right, so I'm going to, so the first thing you're going to want to do is find out your total range, right? And we'll talk about range more later as a numerical calculation. But our smallest data piece is 8. So the fewest text sent a day by a student is 8. And the largest is 400. So you want to take the highest and the lowest, and you want to subtract those. And you kind of get, you start to, based on that range, it says let's create the frequency distribution with 8 classes. So now we're going to set it with 8 classes. And sorry, I'm stumbling here a little bit, but the lower value, the upper value, and now we're going to decide we're going to make 8 classes. So how do we make that happen, right? Well, we've got to create the range first, right? How wide does our data completely cover? So we take our upper value, subtract our lower value, and we get 392. So all of our data ranges between 392 texts. And since we're going to make 8 classes, or we want to make 8 classes, we'll divide that complete range into 8 different even sections. So 392 divided by 8 gives you 49. Now, again, since the class width doesn't really matter, ultimately it's just whatever gives you the best picture of the data, we're going to want to set it to where the intervals are nice, round, whole numbers that are easy to look at and easy to make sense of. So 49 is very odd, sort of off number. I don't want to look at a class and have to try to do some math to figure out what the width is. I want to be able to tell pretty easily. So what we'll do here is we'll go ahead and round it up to 50, right? Nice integer or the nice multiple of 5 or 10 makes this interval pretty easy to look at. So 50 makes sense, right? So now what we're going to do is create a table of 8 classes that are 50 wide, right? And the way we'll do that is we'll start with our lowest. Our lowest number of text is 8. And then 8, and since we're counting 8, 8 to 57 will give you 50 texts wide in terms of a width. I know if you subtract 57 minus 8, you get 49, but we're counting 8 and 57 there. So actually, you know what? This is going to make more sense to adjust this. So if we're going to be 50 wide, then this needs to be a 58. This needs to be a 108. This is a 158, 208, 258, 308, 358, and a 408. Okay? And then we're going to tally up the number of data pieces that fall into each of those intervals. And so we just look. Let's see, between 8 and 58. So there's 1. Well, shoot. Let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. I'm looking to make sure I didn't miss any. So I think we've got 12 here. And so you would tally every time you got one. 5, 6, 7, 8, 9, 10, 11, 12. Right? So we had 12 of our text messages found in, went into that interval. Now, 58 to 108. That would catch that one. So there's one there. Another one there. Another one there. One there. One there. There's one. There's one. There's one. There's one. There's one. And then 80. There's a 75. And an 80. So there's 13 here. And then 108 to 158. Oh, got one. 2. And then 158 to 208. There's 1 there. Another 1 there. And then 208 to 258. There's 1, 2 there. 258 to 308. There's none. As a matter of fact, we don't get to another one until 400, so we put a tally mark there. And so there's our frequency distribution. Okay? That's it. Just tally them up and add them up. Okay? And it looks like that. Okay? Now, it should sum out to 32. That sign I just put down there is the sum. The sum of all of our counts is 32. Now, the midpoint. The midpoint is helpful to find for a couple of different reasons. We'll use it in a calculation later. Sometimes when we create graphs, we kind of center what we end up calling a histogram, which is kind of like a bar graph. We'll center it at the midpoint of our interval. Midpoint, we're finding the middle number of our interval, right? And how do we find the middle number when we've got two numbers? Is that we want to add them up and divide by 2. Now, I did adjust these numbers last time. It did not make a difference in our frequency count. I know that your notes are already set up this way. Actually, you don't have these in there. So, again, I'm gonna change these, right? Make these intervals make a little bit more sense. 8, 8, 8. And if we ever had a data point that landed on, one of these numbers that are in two different intervals, we have to figure out where to put it. But all right, so if we're going to find the midpoint, we're going to take 58 plus 8, right, and divide them by 2. We're just going to average them, right? So when we do that, 58 plus 8 is 64 divided by 2. It's going to give me 32. Right, and then 108 plus 58 divided by 2 is 166 divided by 2, which is 83. And then so on and so forth, right? I'll give you a second, or stop the video, take a few seconds to do the rest of these calculations, and we'll see if we match up. And so there are your midpoints, right? 33, 83, 133, 183, 233, 283, 333, and 383. You kind of start to see a pattern where we're sorting adding 50 every time, which makes sense, right? We should be, since our intervals are 50 wide, right? So there are our midpoints. We're going to center our graph on those, or just use those in the calculation later, okay? Now, that's going to adjust these, and so you'll have to kind of ignore these. Okay, we've done our own calculation, and we're good. Okay? So every time we see these, we got to change these. And that's because we adjusted the interval width to make a bit more sense. Okay, and I know we adjusted these as well. Okay, now next is a relative frequency. Right, and what a relative frequency is, just a percentage, right? So it's the percentage of our data points that fall in a particular interval. So in this first class, there were 12 data pieces that fell in that interval. So we're going to take 12 and divide it by the total number of data pieces that we have, and that will give us the percentage of data pieces that fell in that first interval. So 12 divided by 32 is going to give us 0.375, or 37.5%. right? And then so on and so forth. So 13 divided by 32 is going to give us about 40.6%. 2 divided by 2 is going to give us roughly 6.25%, which is going to be the same for this next and this next. And then the 1, so obviously these are zeros, is going to give us about 3.125%. Okay, now if you add up with the percentages, obviously we should be at 100%, but we're rounding, so it may not be exactly 100%. But that's what we mean by relative frequency, all right? And so these are kind of rounded as well, okay? And again, remember that we've changed these and we've changed these. Okay. All right. Now, your cumulative relative frequency. So this becomes a rolling total of the number of data pieces that fall in an interval or an interval less than it. Right. So we're going to add up our data pieces as we go through. I marked out the midpoint in the text because we've changed those, right, to make a bit more sense to us. And so again, this down below, this is just supposed to show us that the sum of the data pieces is 32. Here we've summed up the data pieces that fell in an interval and divided it by the total number of data pieces. Okay, so our relative frequency there. All right. Now, our cumulative frequency is a running total of how many data pieces fall in that interval or below it. So in our first interval, there are 12 data pieces that fall in it, and there's nothing below it, right? Now, in our next interval, we've got 13. So I've got 13 data pieces in there, and I've got 12 that fall below it. So I'm going to add those and get 25. And every time I pick up the number of data pieces that are in the next interval, so I'm going to keep adding. So it lets me know as I progress through the intervals, how many data pieces am I picking up? Okay, so there's your cumulative frequency. Okay, and then you see it there. And then for now, for our frequency distribution table, we'll stop there. We will talk about cumulative relative frequencies in a little bit later when we start talking about graphing what are called ogives. But for right now, this is a distribution table that we can do a lot of things with in terms of possibly graphing it and making some graphical displays and just kind of giving us an overall sense of our data.